section 211, which is titled, How Can I Graph It? We're going to be talking about transforming quadratic functions. And so by the end of this period or lesson, I will be able to graph quadratic functions without making tables. You're going to rewrite quadratic functions from standard form by averaging the x-intercepts to identify the vertex. In previous courses, you developed several tools that enabled you to transform graphs of parabolas by altering their equations. In this lesson, you will review transformations of functions and review how to sketch graphs of quadratic functions. Okay? So whenever you're asked to graph a quadratic function, you can always use Desmos, type it in, and it'll give you a parabola. What we're going to look at today is a way for you to not have to use Desmos, but it's in a special form called Vertex Form, and it has a nice name because Vertex Form will give you the vertex, right? Okay, so if we're sketching quadratics in what we call graphing or vertex form, it's going to be easy enough just to look at the way the equation's written.
Oh, I got it.
And see if we can graph it straight and just by looking at the form. Okay? You can always go back later and check yourself on Desmos if you have time, but you should be able to, just by looking at the form, find the vertex, determine if it opens up or down, and see what the stretch or the compression is. Okay? So using arrows, we're going to show how each term shifts the vertex of a quadratic function written in vertex form. So the equation, or the general form of the vertex equation, is y equals a times x minus h squared plus the k. Each of these has a special job, okay? So the h and the k, which will end up being your vertex, are going to move your vertex left or right. And it's always going to be the opposite. So if it's plus 5 right here, you're actually going to move it to the left. And if it's minus 7, you're actually going to move it to the right. Why? Because there's a negative in that standard form. Okay? The k is going to move it up or down. So if it's plus 3, you move up 3. If it's minus 7, you move it down some. Okay? The a's special job is going to either keep it the same or reflect it down, meaning if it's negative, your parabola is going to open down, and it's going to stretch it or compress it. If it's just a 1, it stays. It doesn't stretch or compress. Okay? Here is summary in words. So, the a in the equation tells us if the quadratic opens up or down, and if it is vertically stretched or compressed. The h in that equation is opposite, because there's that negative sign in there, and tells us if the vertex shifts left or right, and that's horizontally, okay? The k in that equation tells us if the vertex shifts up or down vertically. Okay? If there's anything you want to write on that last line, go for it, or just leave it blank. Okay? So we're going to look at the 4 examples down at the bottom, and then on the next page, you're going to work in your group of 4, and you're going to look at the equations, see if you can figure out what the vertex is, if it opens up or down, if it's stretched or compressed, and then graph it. Okay? So let's look at, and I need 2 of these, or I can just use this. All right. Okay, so we have the equation for A. We have y equals 2 times the quantity x plus 3 squared, and then plus the 4. Anybody think they can determine the vertex given this equation? Yes. Anybody have another guess? Yes. Okay, so 3, 4, and negative 3, 4 are both sound right, but one of them is right, and it has to do with the negative sign that's in that equation, right? So let's see. It's going to be negative 3, 4 because you want the opposite of what is there. Okay? So I drew this little arrow pointing to the left because you're going to shift 3 to the left.
What does that say?
It says stretch by 2. Then there's an arrow pointing up because that's going to move your vertex up 4 units. Any questions on A? We're good. Awesome. Okay, look at B and see if we can
0.
determine the vertex of that one. Oh, I want to cover that up. Okay, that gives you a little bit of a hint. Okay, this one seems like a trick, but you guys are too smart. What'd you get?
0, negative 6. I got that too. Yeah.
Nice. Good, because you're both looking at the same equation. That's helpful. So, notice I didn't draw an arrow pointing right or left because nothing is being added or subtracted to that x. So it doesn't shift left or right, but it does shift down 6 units, and then the vertex is at 0, negative 6. Nice.
Thanks for that.
All right. Let's look at letter C. Oh,
I got it.
you already got it.
Yeah.
You're on it. So you're going to do really well on the next page.
I will.
Okay, so we have a couple things happening on C, but does anybody think they can give me the vertex? Ahmed?
Negative 1, 0.
Negative 1, 0 is correct. This one also has a stretch of,
3.
does it open up or down?
Up.
Opens up because it's positive 3. These are actually all positive, so they're all opening up.
Positive.
So we have a stretch of 3, and the vertex should be at negative 1, 0. And we have one more on this page. Who thinks they can get the vertex for D?
Me.
8, 2. Yes, good job. So we've got 8, 2, and we're going to shift. I drew an arrow going to the right because we're going to shift 8 units to the right.
Up 2.
And then I drew an arrow pointing up because you're going to shift that vertex up. This one opens up because it's positive. It has no stretch because there's a 1 out front that you can't see. And that's it. All right. Any questions on A, B, C, or D? Yes. When we're going around, yes. Okay, so turn over to page 3. All right, so you're going to break into your groups of 4. I really think you guys can do this. I want you to try first without Desmos. Give the vertex, describe your shift, sketch the graph if you can. If you absolutely have to, or when you're finished, if you want to check, you can use Desmos. Okay? And that should get you going.